All right, gonna do the work for the third page of your linear test review. I'm going to graph these two inequalities. They're in the y is greater than mx plus b form. I'm going to start on the y-axis at -5. And again, I'm working through these problems pretty quickly. I'm going to treat my slope of 2 as a 2 over 1, up 2 to the right 1, up 2 to the right 1, and plot points. And then I'm going to look. It's strictly greater than, not or equal to, so I need to make this a dashed line. I like to just put my dashes through those points I plotted. And then it reads y is greater than, so go to the y-intercept, and the y-intercept is down here. I want to shade the side of my graph where y is bigger than the y-intercept, which means that I'll shade on this side of the line all the way across. When I look at the second problem here, what I realize is it's not in that y equals mx plus b or y is greater than or less than mx plus b. So the first thing that I'm going to do is solve for y without losing my inequality symbol. I'm going to subtract 5 x's from both sides. In this case, -3y is less than or equal to -5x minus 15. To finish, I need to divide everything in the problem by -3. Again, dividing by a negative number means that I need to change my inequality sign. It was less than or equal to. Now it's greater than or equal to. -5 divided by -3 is going to leave me with a positive 5/3 x. -15 divided by -3 is going to leave me with a positive 5. My y-intercept is the positive 5. From there, I need to use my slope of 5/3. Now, I don't have room to go up 5 and to the right 3. So what I'm going to do is think about how the fraction 5/3 is also equal to -5 over -3. That will give me the ability to go down 5 to the left 3. Down 5 to the left 3. Now going back to the details, where's my equation? Geez, sorry. All of a sudden I have a scratchy throat and I'm sneezing. Great. Y is greater than or equal to. I'm going to make it a nice solid line. Greater than or equal to. If I go where the y-intercept is, that means I need to shade above it. Greater than the y-intercept. So I'm going to shade this whole side of the line for that problem. Now moving on. Many entertainment venues offer special pricing for large groups. 2013, a single-day ticket at Cedar Point costs $35. For school trips with 15 or more students, the single-day ticket is $25. If 10 people plan a trip to Cedar Point, how much would the tickets cost? Well, if it's not a group of 15 or more, I don't get that discounted rate, so it's going to be 10 times $35 a piece, or $350. If 20 people attend, I do get the discounted price. So 20 times 25 is actually equal to $500. Did that in my head. 10 times 25 is $250, so I doubled it. Write a piecewise function for the total cost of the tickets for the entire group as a function of the number of people in the group. So f of x is 35 times the number of people in the group if x is between 0. Well, would I even have 0 people? No. More than none, less than 15 people. Or you could write this as, why don't we do this? Up to and including 14 people. The other function would be 25x if the number of people is greater than or equal to 15. Sketch a graph of the piecewise function. Well, what I'm going to do is I'm going to come down here and label these by 2's. And then I'm just going to go do some math to get me some points on this graph. 16, let me go up 18, 20. And I'd like to find out some of the maximums so I can set my scale here. If I sell 20 tickets, I'm just going to do some math over here. 20 tickets would be at the 25 rate. Oh, I already had that. That's $500. So actually, I think the highest I'm going to get on my graph would be to 500. Ooh, I want to double check something though. What if I did take 14 people? 14 times 35. I wonder if that's more just because the ticket prices are more. 14 times 35, it's actually not, it's 490. So really the highest amount I need to get to on my graph is 500. Let's see if this would work. If I do 25, 50, 75, and 100, I think I'm going to be fine. 25, 150. I don't like how this is looking. This is going to get me to, oh, there we go. There's 50. There's 100. 25, 50, 75. There's my 200. 150 would be here. 250. 300. 350. 400. Ooh. Ooh, 450. My 500 is going to come up top. That's okay. All right, I have 1 point over here. I know at 20 I get up to 500. And I actually figured out that at 14 I get up to 490. 490. So now I just need to go and fill in. If I have 0 tickets, I'm not paying any money. If I have 2 tickets, I'm paying $35. That would put this at 70. If I have 4 tickets, 4 times 35 would put this at 140. 6 tickets, 6 times 35 would put this at 210. 8 tickets at $35 would put this at 280. 10 tickets at $35 would put us at 350. 12 tickets at $35, $420. 14 tickets is there. Now I make a jump, because when I go to 15 tickets, my price changes. 15, I don't need, I should graph 15. 15 times 25, I've got the reduced price. 15 times 25 is putting me at 375. Oh, I think my scale's off a little bit over there. That's all right. 16 times 25 is putting me, 16 times 25 is putting me at $400. 16 to 400. And I've already got a point over there for the other, so I'm going to do that. This line is less steep than this one because of the fact that it costs less. Sketch the graph, got that done. This is going to be my cost in dollars. I got to put that over there. What's the largest number of tickets that can be purchased with $400? Well, with $400, it looks to me like I can get 15 tickets. Over here it intersects at, what, 11? But right here it intersects where I could actually pay for the 15 because it was $375. Cool. Good luck.